Just look at it floating there. A reptile spending its day soaking in a muddy river, completely motionless. It looks sluggish, heavy, and perfectly content to do absolutely nothing. Yet this exact biological design survived the mass extinction events that wiped out the dinosaurs. They've been sitting in these waters, physically unchanged, for over 100 million years. That survival record comes down to a specific hidden skill set. These reptiles run constant instinctive calculations involving fluid dynamics, optics, and geometry. To see exactly how these calculations work in the wild, we can track the underlying physics of a single, perfectly executed ambush from the moment the predator enters the water. The hunt actually begins at the bottom of the riverbed. By swallowing heavy, fist-sized stones, the animal adds over 10 kilograms of dense ballast to its stomach. This extra mass exactly cancels out the upward pull of its air-filled lungs, achieving perfect neutral buoyancy. This chart shows the physiological impact of that ingested rock. Without it, a dive lasts around 6 minutes. With the stones acting as an internal anchor, the average dive time shoots up to 35 minutes. While submerged, those air-filled lungs operate like steerable balloons. By shifting the lungs toward the back, the animal tilts nose down into a dive. Slide them sideways, and the body rolls silently, maneuvering without causing a single ripple at the surface. Once in position near the surface, the predator exploits refraction, the bending of light as it moves between water and air. This creates a specific optical effect known as Snell's window, projecting a compressed 97-degree view of the territory above straight into the animal's eyes. Because of how that light bends toward the surface, a prey animal looking down sees completely distorted visual information. The optics scramble the shape of a massive predator into harmless floating debris. By balancing its internal mass and aligning itself precisely at the boundary of water and air, the predator turns the river into a one-way mirror, waiting in absolute stealth. Along the edge of the jawline sit rows of small black bumps. These are hypersensitive sensory organs that act as a radar array. They detect microscopic changes in water pressure, allowing the animal to pinpoint a target from a disturbance as small as a single drop of sweat hitting the surface. Once a target is locked, the tail propels the body forward at 20 miles per hour, closing the distance instantly and delivering a crushing blow of up to 3,700 pounds of force. But securing a large mammal creates an immediate mechanical problem. The teeth inside those jaws are sharp, conical hooks. They are built specifically to puncture and grip, lacking any flat edges to slice or chew through flesh. To process food larger than its throat, it applies the principle of angular momentum. This specter graphic illustrates the technique. The animal bites down and violently pulls its legs flat against its body, instantly shrinking its physical radius. By decreasing its width, the inertia shifts. Without expending any additional muscular energy, that tighter radius forces the entire body to spin several times faster through the water. The resulting torque twists the massive prey, generating enough kinetic friction to cleanly tear through solid muscle and snap bone. This rotational force entirely replaces the biological need for molars. The chaotic, violent thrashing is a highly efficient mechanical process that converts rotational inertia into localized destruction. Once the meal is secured, the predator sinks to the riverbed to begin the internal breakdown. The engine driving this process is a 4-chambered heart equipped with a highly specialized biological valve called the foramen of Panizza. This schematic demonstrates how that specific valve functions underwater. It actively shuts off the blood flow that normally goes to the lungs, since the animal isn't breathing, and redirects that carbon dioxide-rich blood straight into the stomach cavity. Flooding the stomach with CO2 triggers a massive chemical reaction. It accelerates the production of gastric acid to a rate 10 times faster than any mammal, creating a highly corrosive environment capable of dissolving hooves, horns, and pure bone. Every single part of the prey is broken down and absorbed. This intense chemical extraction yields an enormous caloric surplus, providing enough fuel to keep the animal alive for up to 3 months off a single kill. It is a closed-loop system of internal plumbing that guarantees absolute zero waste, perfectly maximizing the return on the immense energy spent capturing the prey. With its internal tanks completely full, the animal returns to the riverbank. Here, it relies on its dark, armored skin to absorb the full spectrum of solar radiation. A mammal of this size would burn through a massive percentage of its freshly eaten calories just trying to maintain its core body temperature. By relying on external solar energy to heat its blood, this reptile keeps all its ingested calories locked away in storage. Even while digesting and resting, the defense systems stay active. It utilizes unihemispheric sleep, shutting down half of its brain to recover, while leaving the other half, and one eye, wide awake to monitor the surroundings. We started by observing a creature that appears primitive and slow, asking how it managed to outlive the dinosaurs without needing a major anatomical update. The answer is found in its efficiency. It dominates its environment by seamlessly integrating fluid dynamics, geometry, and thermodynamic principles, surviving purely by letting the physical laws of the universe do the heavy lifting.